Sir, can you see on the top in the bar URL where you're typing this KMIT online? There is one red hyphen. There is a pop-up there.
Okay.
Hello, Srinivas sir. Sir,
Sir.
just start sharing your screen, sir.
Okay. I should record. First go with record.
First,
No?
click on record, sir. Yeah.
Okay.
Click on
Security wise,
record.
it's okay.
Yes, sir. Click on record and disable annotation and start the.
What is annotation?
Sir, there is one option of disable annotation. Means students can start scribbling then.
Where is it?
Sir, it will come there only, sir. The other day I showed you up. In near that record option only you will get it.
There is no option. Only chat, share screen and record.
Okay, fine, sir. Start recording and click on share screen.
Okay. Shall I start, sir?
Yes, sir.
Okay. Good morning, students. So we will be starting with the fourth chapter today. In the last three classes, Uday Lakshmi madam has covered the first three chapters. Today we'll see the fourth chapter. The fourth chapter is lasers and fiber optics. So introduction to laser. Laser as the definition goes by It is light amplification by stimulated emission of radiation. It is actually through a device where optical amplification based on stimulated emission of radiation can be achieved. In theoretical concept, the word laser and a concept of laser was first put forward by Albert Einstein. And the first developed practical laser was done by T.H. Maiman. Now, properties of lasers. Laser is a highly monochromatic light, meaning it has single wavelength. It is a highly directional light. It travels in straight line. It is a highly coherent light. Coherence means two laser waves maintain a constant phase difference. It is a highly intense beam of radiation. Now, before going into the nature and types of lasers, let us see the three important optical phenomena, which are called as absorption, spontaneous emission, and stimulated emission. Absorption. In the process of absorption, consider two energy states E1 and E2. The atom will be in the lower energy state. Now, if this atom is supplied with one photon of energy or the difference of the two energy states E2 minus E1, then the atom absorbs this energy in E1 and makes an upward transition. This process is called as absorption. Atom is in the lower energy state, it absorbs one photon of energy and goes to the higher energy state. This is called absorption. In spontaneous emission, again we consider the two energy states E1 and E2, but now the atom is in the higher energy state, E2. It is not in the lower energy state. An atom can exist or stay in a higher energy state up to a time of 10 power minus 8 seconds, after which it automatically loses its energy and comes down to the lower energy state. But if it comes down to the lower energy state, then it will emit one photon of energy. It will emit one photon of energy. The third is stimulated emission. In stimulated emission, the atom is again in the higher energy state, E2. If I wait up to a time of 10 power minus 8 seconds, it will automatically come down to the lower energy state, emitting one photon of energy. But I am not interested in waiting for up to 10 power minus 8 seconds. So what we do, please see this. I am triggering this energy state E2 with one photon of energy. Triggering the energy state. Triggering the energy state is the other way of saying weakening the energy state. I will weaken the energy state. When I weaken the energy state, whatever atoms stay in the high energy state will automatically make a downward transition. They will come down to even energy state. But if it comes to even energy state, it will again emit one photon of energy. I have supplied one photon of energy and it is emitting one photon of energy. Both the photons of energy add up together and it will form two photons of energy. This is stimulated emission. The difference between spontaneous emission and stimulated emission is, in spontaneous emission, atom makes a downward transition on its own after a time of 10 power minus 8 seconds. But in stimulated emission, we do not wait up to 10 power minus 8 seconds. We trigger the energy state, thereby de-exciting the atoms in the higher energy state to make a downward transition, and they come down by emitting a photon of energy. The photon of energy we have supplied, the photon of energy emitted by the atom add up together to form two photons of energy, double the energy. This is stimulated emission. Next, applications of lasers. There are wide applications of lasers, which are categorized into two categories: low power applications and high power applications. In low power applications, you have communication, metrology, reprography, and entertainment. In high power applications, you have military, chemical, medical, and heat source applications. These are the various applications. Next, two other important topics are population and population inversion. Population. Population of an energy state is nothing but the total number of atoms present in any energy state. The total number of atoms present in energy state is called as population of the energy state. If suppose an energy state consists of 4 atoms, then 4 is the population of the energy state. If an energy state contains 8 atoms, then 8 is the population of that energy state. Next, population inversion. This is a very interesting topic. In any situation, a lower energy state will be having more number of atoms than the higher energy state. That means lower energy state is more populated than higher energy state. But if a higher energy state is more populated than the lower energy state, then we say that population inversion is achieved. I repeat, if higher energy state consists of more number of atoms than the lower energy state, then we say that population inversion is achieved. For obtaining laser radiation, we need population inversion. We need population inversion. Try to recollect the stimulated emission example. In the stimulated emission example, atom was existing at the higher energy state E2, but there was no atom in the lower energy state E1. That is population inversion. Higher energy state should be more populated than lower energy state. And the ratio of population of two energy states, E2 to E1, minus delta E by kT, e to the power of minus delta E by kT, where delta is the difference of the two energy states, E2 and E1. Here you see N2 by N1 is given. N2 is the population of higher energy state and N1 is the population of lower energy state. Okay. Next. Laser components. Components of laser. Laser consists of three components. To produce laser radiation, you need three components. One is called energy source, that green color bar you are seeing. Second is active medium. Below that one, there's a cylindrical pink color rod. That is active medium. Third is optical cavity. You see two mirrors, two blue color vertical bars as adjacent to the cylindrical rod. Those are called as optical cavity or optical resonators. It consists of two mirrors, one fully reflecting and the other partially reflecting. Energy source is one which supplies energy in the form of flash lamp or electrical energy or through a chemical reaction to the active medium. An energy source is also called as a pumping source. It is basically a system providing energy to the active medium. Now, what is active medium? Active medium is also called as gain medium. An active medium or a gain medium is one which has the capability to produce laser light. For example, energy falls on active medium, then will produce laser light. Fine. Example is, all of you might be knowing ruby in all of you might be knowing ruby. Ruby is a crystal, a small crystal. In Telugu, you call it as kempu. Okay, ruby. When light falls on ruby, external light falls on ruby, then ruby emits some internal light. That internal light emitted by ruby, so ruby is an active medium, or also called as gain medium. The third requirement is optical resonator. Optical resonator consists of two mirrors. One is fully reflecting and the other is partially reflecting. Now the question is why one should be fully reflecting and the other should be partially reflecting. The reason is when laser light is emitted, it is emitted in both the directions. So to streamline it into only one single direction, one is made fully reflecting. So whenever light falls on the fully reflecting mirror, for example, in the diagram you can see the left side, dark blue color vertical rod, it is a highly reflection mirror. So when light falls on this particular mirror, then it reflects back onto the other mirror. So light emerges only through one direction from the partially reflecting mirror. Fine. Next. Einstein coefficients. Just try to remember this one because derivation is very rarely asked. Einstein coefficients, there are two in number. One is A and the other is B. It is basically a ratio between the spontaneous emission and stimulated emission of a system. It is the ratio between spontaneous emission and stimulated emission of the system. And the ratio is given by 8 pi h nu cube by c cube. The ratio of spontaneous emission. A21 is called as Einstein coefficient of spontaneous emission. B21, below that one, it is the stimulated emission coefficient. Stimulated emission. A21 is spontaneous emission. B21 is stimulated emission. The ratio of spontaneous emission to stimulated emission is equal to 8 pi h nu cube by c cube, where h is the Planck's constant, nu is the frequency of radiation, and c is speed of light. Just try to remember this formula. This formula can be asked usually in the generally university will ask you in internal examinations, objective examinations. That's all. Next, we'll see three types of lasers. This is the first laser that was discovered by a scientist called Maimon, T.H. Maimon in 1960. Now, what exactly is Ruby? Ruby is actually aluminum oxide, Al2O3, but some of the aluminum atoms are replaced by chromium ions, Cr3 plus ions. That is why chromium is pink in color. That is why Ruby appears to be pink in color. In Telugu, you call Ruby as Kempu. It is Navaratnallo oka ratnam adi. It's a gemstone. Okay. Some of the aluminum atoms are replaced by Cr3 plus chromium ions. And this replacement usually will happen by weight. So if 99.95% of the Ruby consists of aluminum oxide, then 0.05% by weight will be replaced by Cr3 plus ions. Because of presence of chromium, the rod looks pink in color. Okay. Now, we need to discuss three things here. Energy, medium, the energy source used in production of Ruby laser is xenon flash lamp. You see this? There are circular coil here. The central cylinder that you are seeing is a Ruby rod. The Ruby rod is wound by cylindrical helical xenon coils. Okay. And the coil is connected to an external power supply. Whenever you switch on the power supply, the helical xenon lamp will glow and the light falls on the Ruby rod. Ruby atoms get excited and they emit laser radiations. At the end of the rod, you have one fully silvered mirror at the left and partially silvered mirror at the right. And the light emerges to the partially silvered end of the rod. Let us see the energy levels of Ruby. It consists of an active medium, which is a rod of Ruby crystal. Optical resonator consists of two mirrors. And the pumping system Now, see the energy levels. For Ruby laser, there are only three energy levels, E1, E2, and E3. So it is called as a three-level laser. Please remember. Since there are only three energy levels, it is called as three-level laser. Now, initially, all the atoms of Ruby are in E1 energy state. E1 is also called ground state energy. Once a flash of light from xenon helical coil falls on Ruby rod, then all the atoms get excited to E3 energy level. When a flash of light from xenon falls on Ruby rod, then all the atoms get excited to E3 energy level. Between E3 and E2 energy level, there is one energy level which is E2. E2 is called as the metastable energy state. That means the lifetime of atoms is more at metastable state. Atoms can stay for longer duration of time at E2 when compared to E3 and E1. From E3 energy state, Ruby atoms spontaneous emission will take place and they will come down to E2. That means after a time of 10 power minus 8 seconds, all the atoms from E3, they will come down to E2. But here, what happens? They stay for a longer duration of time since E2 is a metastable state. Now what will happen? One atom of ruby from E2, it will come down to E1 spontaneously after 10 power minus 8 seconds. This atom, when it comes down spontaneously from E2 to E1, it will emit one photon of energy. This photon of energy now, it will stimulate other ruby atoms of E2. It will stimulate other ruby atoms of E2, and stimulated atoms of E2 will come down slowly to E1. But when they come down, they emit a radiation, which is laser radiation. I repeat the process. Please remember, ruby laser and helium neon laser can especially be asked in this year external examination. The reason being, they are simple in their nature and construction. So they are not complex. So usually ruby or helium neon can be asked. Please, I am repeating the energy process once again. Ruby laser consists of three energy levels, E1, E2, and E3. Only three energy levels. So it is called as a three-level laser. It is called as a three-level laser. Also, it is called as a pulsed laser. The reason being, xenon flash lamp does not give continuous light. It will give it flashes. One flash of light will fall and it will stop. Flash of light will fall and it will stop. So it is not continuous, it is discontinuous. So it is called as pulsed laser. Ruby laser is called as a three-level laser or as a pulsed laser. Initially, all the atoms of ruby are in E1 energy state, also known as ground state. Now, when one flash of light falls on ruby, then all the atoms get excited to E3. From E3, they spontaneously come down to E2. But E2 is a metastable state. One photon, the first photon which comes down from E2 to E1 will now trigger E2 energy state. That means it will cause stimulated emission at E2 energy state, then and all the atoms from E2 will come down to E1. But when they come down from E2 to E1, they will emit a light which will be laser radiation. The same process is explained here. Usually, the light wavelength of light emitted by ruby laser is 594 angstroms. Is 5943 angstroms. All these notes, I will send it to you. I will upload it after the class. If possible, today or tomorrow, we have a second part of it. The fiber Am I audible to all of you? Am I audible to everybody? I hope I am audible to everybody one now. Am I audible now? Or just type in yes or something.
Sir, your voice is breaking again.
Now is it audible, sir?
Yes, sir. Now it is okay, sir. Clear.
Okay. Okay, fine. So Ruby laser is basically as three-level laser. It consists of only three energy states: E1, E2, and E3. Fine. So initially, all the atoms of Ruby laser, they are in ground state or E1 energy state. When I flash off from xenon on Ruby, then all the atoms get excited to E3 energy state. From E3, they come down to E2, and from E2 they come down to E1. When they are coming down from E2 to E1, they emit laser radiation. This is basically what is the principle behind E2 energy state. Ruby laser. Now, applications of Ruby laser. They are used in drilling holes and in camera systems, especially holographic camera systems. Most of you might be knowing what is holography. Is three-dimensional photography. In a two-dimensional photography, if you tear a photograph, then you do not retain the complete information in each part of it. But in a three-dimensional photography or holography, even if you tear it into n number of parts, each part will contain the complete information. That is holography. So ruby laser is especially used in holography. And in medical systems, especially in dermatology for tattoo removal and in cosmetic dermatology. Next, we will discuss about helium neon laser. Helium neon laser is a gas laser. Ruby laser is a solid state laser. It consists of a rod or crystal of ruby as the active medium. Helium neon laser, it consists of a mixture of helium and neon gases as the active medium. When the active medium is a mixture of gases, then it is called as a gas laser. So helium and neon gases are mixed in the ratio of 10:1. 10 parts of helium and 1 part of neon in a discharge tube and connected to an external DC supply. The DC supply is the energy source here. Helium neon gas is the active medium. There are two mirrors placed on either side of the discharge tube which acts as the optical cavity. The left one to the discharge tube is a partially reflecting mirror and the right one is a fully reflecting mirror. This is the construction of a helium neon laser system. Now, helium neon laser, the components as we have discussed, it consists of a high voltage DC power supply source as the active energy source. Active medium consists of a mixture of helium and neon gases. Resonating cavity consists of two mirrors, which are one is partially reflecting and the other is fully reflecting. The same thing in a diagram way I am representing it here. Active medium is a mixture of helium and neon gases contained in a discharge tube. They are mixed in a ratio of 10:1. That means for every 10 parts of helium, there will be 1 part of neon. The resonating cavity, it consists of two mirrors placed on either side of the discharge tube. Left side mirror is partially silvered and right side mirror is fully silvered. Now, see the energy level. 5 energy levels. It consists of 5 energy levels. The left side is for helium energy levels and the right side is for neon energy levels. See the energy level E5 energy level for helium and E5 energy level for neon are almost at the same level. So it is called as, so E5 is taken as 1 energy level. So instead of calling it as a 5 energy level, we call it only a 4 energy level. Since E5 of helium and neon overlap with each other, it is only taken as a 4-level laser. Ruby laser is a 3-level laser and helium neon laser is a 4-level laser. Okay. Now, see the energy levels. The highest energy level of helium is at 20.61 electron and the highest energy level of neon is at 20.66 electron volts. Between 20.66 electron volts of neon and the ground state, you have one energy level is 18.7 electron volts. This is the energy level where laser transition occurs. Now, initially, all atoms of helium and neon gases will be in the ground state. Once electrical discharge is sent to the discharge tube, once electrical discharge is sent to the discharge tube, then helium and neon atoms get excited. See, his voice is breaking. See, there is some kind of internet problem in, I'm saying it a very of the, there is some, I'm trying to say it, hope it will be rectified soon. So initially, all the atoms of helium and neon will be in the ground state. Once energy is lost, then they get excited to E5 energy level. Helium atoms go to E5 energy level and they pass on their energy downstate neon atoms. And neon atoms get excited to EF energy level of neon energy state. That is at 20.66 electron volts. From 20.66 electron volts, they come down to 18.7. From 20.66 electron volts, neon atoms come down to 18.7 electron volts. When they come down 20.6 to 18.7 electron volts, then they emit laser light of 632 micrometers. That is E3 energy level. The E3 energy state of neon. When neon atoms come down from 20.66 to 18.7, they emit laser light of micrometers. This is the energy level and principle behind helium neon laser. Working the same working I am showing it here. I'll repeat it once again. Helium neon laser, if you see the diagram, energy level diagram, then level for neon. But the helium fifth energy level and neon fifth energy level are almost same. We consider it as only one energy level. Hence, helium neon laser is a 4-level laser. It is a 4-level laser. Here in helium neon laser, the laser light is due to neons, not because the laser light emission is because of neon and not because of helium. Then you may ask me, what is the purpose of helium? Helium atoms only provide energy for neon atoms to get excited to 20.66 electron volts. All the helium atoms present will give energy to neon atoms to get them excited to 20.66 electron volts. When an excited neon atom passes from 20.66 electron volts to 18.7 electron volts, then it emits a photon of energy 632 micrometers. I'm sorry, not energy, wavelength. When an excited neon atom passes from 20.6 electron volts to 18.6 electron, 18.7 electron volts, then it emits a photon of wavelength 632 micrometers. Length of light emitted from E5 to E3 or from 20.6 to 18.7 electron volt is the laser light. Fine. I am printing here. Please see. And 20.66 both are at the same level. It is considered only a laser, not level laser. Is it audible now? Am I audible? Okay. So I repeat, there are 5 energy discharge tube in helium neon laser, which consists of helium and neon gases in ratio of 10:1. For 10 parts of helium, there will be 1 part of neon. Laser light is because of neon, not because of helium. Laser light is because of neon, not because of helium. Then what is the purpose of helium? Helium atoms help only in excitation of neon atoms from ground state to 20.66 electron volts of E5 energy level. That's all. When an excited neon atom comes down from 20.66 electron volts to 18.7 electron volts, then it emits a photon of wavelength 632 micrometers, 632 micrometers, or 632 into 10 power minus 6 meters. This emitted photon at from E5 to E3 is the wavelength, is the laser light. It is the laser light. Hope this is clear. The same thing I am representing here once again. The stimulated transition from 20.66 to 18.7 is the laser transition. Okay. Applications of laser. Usually in every supermarket we see barcoding. Whatever grocery buy, they are using some kind of red color instrument, but the coding on them is made with a helium neon laser. Again, whatever printing we are going right now nowadays for documents, laser printing, the printer is based on helium neon laser. These are the 2 applications of helium neon laser. The third one is a CO2 laser. I think the audibility is we will end up the here today. We will continue from CO2 molecular laser from tomorrow. We will continue tomorrow. Fine. Yes, I understand that my voice is breaking. Please raise your questions if you have got any. We will continue it here. If still the network connection is a problem, for helium neon laser, the applications are laser printing and in barcoding. Siddharth is asking. Helium laser, the applications are in supermarkets and other one is laser printing. Any other question? We'll stop it here. I will recheck the internet connection today. If the problem still exists, I'll ask some other faculty of mine. I'll hand over the notes to the faculty. I'll ask the faculty to take it. No problem. I am staying at a very far off place, outskirts of the city. So that is the problem here. I'll recheck it once again. And tomorrow I'll see to it that there won't be any problem as far as possible. Any other question? So thank you all. We'll stop the class for today.